For this video, we are going to focus on what we call standard form of a parabola. Let's begin by doing a warm-up. For each of the following parabolas, we need to mark some things on it, just like we did in previous lessons, labeling all intercepts, x-intercepts and y-intercepts, labeling the vertex, marking the axis of symmetry with a dashed line, and labeling it with an equation. I will go through the first one with you, and then I'll have you do the next two. So as we look at the first one, let's look for our intercepts. X-intercepts. Where does my graph cross the x-axis? As you can see, there are two x-intercepts. There and right there. The one on the left is at our origin. We label that 0, 0. The one on the right is at 2, 0. Does our graph have any y-intercepts? As I look at my graph, is my graph crossing the y-axis? It is, right here, which we already labeled as an x-intercept. So an intercept could be an x-intercept and a y-intercept. Vertex. Here is our vertex. The coordinates of that point are 1, -2. Okay, I'm going to put a V in front of it to represent vertex. It is a minimum. It doesn't ask us for that, but as a reminder, it is a minimum. Our axis of symmetry. Our axis of symmetry is the line that splits our parabola in half going through our vertex. And they want the equation for our axis of symmetry. It's a vertical line, so it always begins x equals. Because it goes through our vertex at an x value of 1, my equation is x equals 1. Please hit pause and work through the next two. Then resume to check your answers. On the second graph here, my x-intercepts occur at -6 and -2. My y-intercept occurs at 0, -6. My vertex is -4, 2, and the equation for my axis of symmetry is x equals -4. On the last graph, my x-intercepts are at -2 and +2. My y-intercept is the same as my vertex, 0, -4, and my axis of symmetry is x equals 2. Standard form of a quadratic equation. All parabolas come from quadratic equations. As we learned in Unit 8, quadratic means an exponent of 2. So all quadratic equations are in the form y equals ax² plus bx plus c, where a, b, and c are numbers, and a cannot equal 0. The a value is always in front of our x². The b value is always in front of the x, and the c value is a constant. As I look at the first one, y equals x² plus 7x plus 10. My a value, what's in front of my x²? Well, there's nothing there. Does that mean it's 0? No, it is a 1. My b value is what's in front of the x. It's a +7. Make sure to always bring the sign with you. And my c value is +10. Please hit pause and work through the next three. Compare your answers with what I've listed. Standard form means our exponents are in decreasing order, starting with the x², and then if there's an x term, and then there's a constant. That helps us to easily identify a, b, and c. Well, why do we want to know what a, b, and c are? If we have a picture of a graph, it's easy to determine the vertex. I can look at a parabola, and as long as it's on a coordinate plane, I can identify the coordinates of the vertex. But what if there isn't a picture? What if I'm just looking at an equation? Well, looking at the a, b, and c value is going to help us determine that. So let's talk about the importance of a, B, and C. Let's sketch the graph y equals negative 2x squared plus 1 by answering the questions. Does the parabola reflect over the x-axis? In last week's learning, what value determined if it reflected over the x-axis? The a value. Because my a value is negative, then my graph is going to reflect over the x-axis. Does the graph shift up, down, or no shift at all? The c value tells me the shift. Because it is a positive 1 plus 1, it is going to go up by 1. Does the graph become more narrow, wide, or no change? For this, I'm going to take a look at the number in front of my x squared. I don't worry about the negative, but I take a look at the number. Because it is 2, because it is something greater than 1, my graph is going to be more narrow. So what are the two things that a determines? My a value here, the negative, determined whether it reflects over the x-axis and whether it was more narrow or wide. The c value determines our vertical shift. Okay, whether my graph shifts up or down. Taking a look at the next page, student practice to fill in the chart. So they've given us 6 quadratic equations. From that, we want to determine the value of a, whether it reflects over the x-axis, if it's narrower, wider, or unchanged, the value of c, and what is the y-intercept. Let's do the first one together. Y equals 2x squared plus 1. My a value is 2. Will this graph reflect over the x-axis? Because my a value is positive, the answer to that is no. Because my a value is greater than 1, my graph is going to be narrower. I'm going to put that with an N for narrower. My c value is positive 1. Guess what, guys? The c value is also our y-intercept. So if my c value is 1, my y-intercept is 1. Please select pause and finish the table. As you see the answers, select pause to compare yours with the table. We talked about if you are looking at a graph, you are able to easily see the vertex and the equation for the axis of symmetry as long as you had a coordinate plane there. So let's learn how to do this without graphing, without seeing the graph. To find the axis of symmetry in a parabola from a quadratic equation, we are going to use an equation. Our axis of symmetry always begins x equals. X equals the opposite of b over 2a. So we need to know our b value and our a value in order to find this. Let's look at the first example. Y equals x squared plus 2x plus 1. Find the axis of symmetry. Well, my a value, that's what's in front of my x squared, it's 1. My b value is a positive 2. So let's plug those values into our formula to find the equation for the axis of symmetry. X equals the opposite of b. Because b is 2, the opposite of that is negative 2 over 2 times my a value of 1. Well, negative 2 divided by 2 is negative 1. So how I want to see this written, x equals negative 1. My axis of symmetry is a vertical line. We need to have the x equals in front of that. Select pause and work through the next 2 examples. For the second example, you should have gotten the equation x equals 3. And for the third example, the equation x equals 1. What is always located on the axis of symmetry? If we think about our parabolas, my axis of symmetry is right here. What is always located on my axis of symmetry? That point right there. And what is that point? Our vertex. So now we have some more information to locate our vertex. To find the vertex from an equation. Well, up above, we already found the x value. To get the x value of my vertex, I'm going to use the equation for my axis of symmetry. The opposite of b over 2a. Once I have my x value, to get my y value, I'm just going to plug that x value in. So what I'm going to write here is plug it in. The first example, given y equals x squared plus 2x plus 1, use the axis of symmetry from above to find y. You'll notice this equation is the same as the first one up here. Okay, we found the axis of symmetry to be x equals -1. So that means -1 is the x value of my vertex. To find the y value, I'm going to substitute -1 in for x. And we always put that in parentheses. -1 squared is 1. 2 times -1 is -2. And then plus 1. 1 subtract 2 is -1. Plus 1 is 0. So the y value of my vertex is 0. Select pause to work through the next two. They do match the second and third example from above. The coordinates for the second vertex are 3, 0. The coordinates for the last one are 1, 3. As a reminder, when we do order of operations, exponents first, 1 squared, then multiplied by the -2.